Hello everyone, this is lecture 19 of Advanced Drilling Engineering, PTRE 451545. I did post the homework, the exam results I had Kalu upload them on Blackboard and they were there. I thought they were available to you guys, but they were hidden. So they were available 2 days before they actually became, I thought they were available 2 days before they actually became available. So apologies for that. They were there, but they were hidden. So I guess if you could take your total grade in aggregate wise on Blackboard and you subtracted everything that was visible, you could have calculated your score. But anyway, I mean, they are fully available right now. Lowest grade was 28, highest grade was 100, average was 77, so not bad at all. I also uploaded homework 4, which we should go over today, and I believe it's due on Friday. It's a very easy homework actually, but it's not. It requires some work. Homework 4 due on April 4, and now it's April 1. So we need to go over it. And then you have a project part A that is due on the 8th. And I believe that, what's his name? Kalu sent an email to everybody who's not yet paired up. And hey guys.
Yeah, hi.
He sent an email to everybody who's not paired up and tried to make some pairings himself. So that, because I want you guys to, the first part of the project is very easy. And I want you to use it to learn the simulator because the second part won't be easy. Also, this is why I don't have it due later. Hypothetically, I could have the project due towards the end of that week, of next week, but I prefer not to give you guys more time. Now, if we make it there and there is a lot of people requesting deadline extension, I can push it back up to like April 10 or 11. But then what is going to happen with the part B? Because part B would be hard there and you will need to know it very well. I mean, this is going to be a very busy month, extremely busy month. You have 2 homeworks, 2 projects, parts of the project, I guess. And then we need to prepare for the final as well. And the most important module is the one coming up, module 4. And I want to spend time on that module. I want to have time available to spend on module 4. I don't think we are behind. We are a little bit ahead compared to last year, I think. But yeah, I mean, you never know. Oh yeah, another thing, important thing. There is a company called Core Geologic. They are looking for 2 young geologists for the back end, not an internship, but full time. They sent me an email yesterday. We are looking to hire 2 young geologists for on-site work in the back end. It sounds like a mud logging job. Who should I and I'm gonna forward them to, I guess, call it career services. But I mean, if you guys, if any of you want to share with me their resume, I can send it over to them. I think that will give you a little bit of a priority. But this is full-time on-site geology. It means well site geology, which means surface logging, which really means mud logging. Probably they're gonna start you as mud loggers and then rise you up to geosteerer, and then either geologists from the office for multiple wells or directional driller or something, depending on what services they are offering. But this is good people, and it's, I guess it's gonna be in the back end, so it's gonna be a tough winter. but I don't think it's a temporary job. I mean, it's a temporary. You are gonna ascend through their ranks anyway. So I will send it to other professors, and I will send it to also Deb Ostreng, whatever her name is, for the career services. No, she's not the career services. She has alumni relations through CEM. So I will get that through them. But I think if you guys want, any of you guys are interested in that job, if you send me your CV, I'm gonna give you. It's gonna give you priority because I will send it to my contact in that company, and I will try to.
You will send.
Put a good.
Yeah. You say it's a temporary job? No.
No, it's a temporary. Well, you're not gonna stay there in that position for 10 years.
That's what I meant.
The idea, but it's a full-time job in the summer. Let me just see.
I have to be geologist. No.
No, you'll be fine if you want to. We're looking to hire two young geologists for on-site work in the backend. There is nothing just for the summer, so it's not an internship. It's a full-time. So if somebody is graduating and is looking for a job, yeah.
Yeah, we have a lot of them.
Yeah. Are they willing to take an international student without?
It doesn't matter because you're gonna be graduated, so you're gonna be on your OPT. They can hire you as any American. In fact, for OPT they don't even need to sign anything. So you just need to file the I-9 form, which is what everybody, so that they can pay you, and you have social security number and everything. I think for OPT they are hiring you as an American.
Yeah.
Then for STEM OPT, you finish the year, STEM OPT, you're graduating this summer?
No.
Okay. So for STEM OPT, I was gonna say in 2027, but for STEM OPT, they need to file, sign something for you, but it's nothing. It's just saying that the job is related to your degree, and this is what you are gonna. And these are very easy to do, and the company needs to be e-verified, and those companies are all e-verified, or you can check. Most of the companies that employ over 10 people are e-verified. So it will work for keeping you 3 years in America after you graduate, in a sense of 1 year of OPT and 2 years of STEM OPT, but it's gonna be a rough job in the field. So the kind of job that when you start working, you look for another job immediately, right? It's just to buy you time. Right?
Yeah, you learned, and I'm sure after that you get a lot of experience.
Yeah, now did I tell you about OPT? No?
No.
Back in my day, I got confused. But when you get the OPT, there is an option to click that you work for yourself. Okay, so it's gonna say like, who do you work for? I work for this company, and underneath you have a box that say I work for Roxon Alua.
Okay.
And my name is Roxon Alua. In that sense, if you click that, I would suggest when you get your OPT, regardless of who do you work for, maybe you want to press that box and keep it like that. So it says that you are still, you are working for yourself. This way you don't accumulate days of unemployment, because if you make 90 days of unemployment, you are have to leave, right?
Okay.
Okay, this way you don't do the days of unemployment. I didn't know it, and I got my OPT on July 20th of 2021, and I started working on the oil field August 9 of 2021. So I got like 20 days of unemployment. They became 70 left. So when you get your STEM OPT, they give you 30 days on top of what you have left from OPT. So for me, it was 70 plus 30, 100 days of unemployment during my STEM OPT. But I could have had 120, right? So say if I lost my job during my stay on PTRE, I want every day available to find another one, every unemployment day.
Yeah.
So I suggest you do that. This is what I did back then in 2021, but it was a mess. In 2021, the whole thing was a mess because I applied for my OPT on January 2nd. I graduated December 18, and I think I didn't get it until, and I got 2 RFEs along the process, but I didn't get my OPT until July 20th. So 8 months, almost 9 months.
Why they giving you RF?
Huh?
Why did they give you RF?
One time something was wrong on the form, the other time they were missing something. It's a request for evidence,
Yeah, more evidence.
RFE. But I made an LLC at the time with my former girlfriend in April 21. And I was basically working for that. And then there is ways you can do it. You don't need to do an LLC to say that you are working for yourself. But from my understanding, at least that was the case back in the day. So, the important thing is not to accumulate unnecessarily unemployment days. And it's good to have an easy job. Yeah, I mean, the jobs in the oil field are very hard, but they give a lot of money.
It's good. I like you experience. You get experience. Yeah, you work for some time, so you get the experience.
Yeah.
Yeah, and if you work there, you and let's say 2 years, 3 years, yeah, a lot. You can get jobs outside somewhere if
Yeah.
you are no more working with them. You can get opportunity, because of the training and then the experience you had on the field, which is good.
Yeah, they will train you. They will
Yeah.
definitely train you. They will send you to train and train you. Yeah. In us, now, they send us in Midland and for training.
Mhm.
And every year you have to repeat some of the training. So those are good
Jobs.
good, how do you say that you have to go through the training. What you get when you go through the training, not permits. When you pass some training,
Promotion.
no, they are, anyway, I don't remember the name, but it's good, makes you more attractive to another company to hire you.
Yeah.
Especially if you guys, I mean, this is not the kind of job that will get you that, but if they pay for you to go through well-controlled certification, that would be good.
Yeah.
Because after you take this class, you should be, you know more than what you need to take the well-controlled certification. So it's gonna be more details and it's more rigorous 3 days. But they are still gonna ask you the same stuff, like they are gonna ask you the kick indicators. They are gonna ask you how you do weight and weight method. They're gonna not learn. They're gonna ask you how to do driller's method. It's the same thing. And then at the end, you take an exam. And then if you pass the exam, you get the certification. The certification is good for 2 years. And then you can move on to the next step, the next step, the next step. And I think the last step is instructor level, and so on and so forth. The first is fundamentals of drilling with stack qualification of the something like that. It's basically well-controlled fundamentals, what we do in this class, which we go over that level because we do other stuff too. Yeah.
And let me ask, how does job opportunity works here in the US? For instance, you are doing your PhD and your research is reservoir engineering, for instance, and you finish job opportunity in drilling comes up.
That's not a problem. I think any engineering job or remotely, even this is a geology job and it still counts as related to petroleum engineering. Yeah, anything that you can establish, any connection, because I think the connection to your degree part, you're gonna write it in the form that you submit. It's a government form, and it could be like, I took classes on resource economics, so I'm doing cash flows for
So,
the company. It can still work.
so any of us, even if you don't have a company, you can go for the drilling, well control, certification exams.
Yeah, but it's gonna cost you
How
like
much?
over $1,000.
But if it will give you an edge over somebody, well, in terms of
Yeah,
applying
I
jobs,
mean, maybe.
I think
I
that-
wouldn't give, no, I wouldn't give that. And then it will expire in 2 years.
Oh, quality.
Yeah, because I took mine on January 27, 2013.
And it's expired.
It expired. It was never renewed.
Yeah.
So
Yeah.
they expect you to pay another money.
Well, I have to go through it again, hypothetically.
Like,
right?
And pay the same amount.
And I think like,
No, we didn't pay it because they were coming to Texas. They liked our drilling professor. And, well, I don't know if it was him who did it, but they were in good terms. While Well Control was in good terms with our drilling professor, and they were coming over and they were making a class on January over a weekend. And they were bringing their own simulators, and they had spots for like 20 people. And you had to apply to get in, you had to have the class of drilling passed. And if there was competition, they would, excuse me, pick up the one with the highest grade and stuff, and so on. But it was first come, first serve until the spots fill up, and then we decide. And the one who gets, it was like they will split us in groups. You decide who is in your group. They do like a draft. And there is 4 simulation exercises during those 3 days. And your group, every time a simulation is done, one group wins. Okay? And if your group wins, and then you all take the exam individually, and you have to pass the exam to get the certificate. I saw one guy in my class didn't pass the exam. So there was a serious, but I think if you don't pass the exam, you don't have to take the whole thing again. They give you another chance to take just the exam or something 1 month later or something. But yeah, we had a guy who didn't pass the exam. But anyway, if your group wins one simulation and you do well on the exam, I guess, they choose you as the best of the class and they give you the belt thing, which is supposed to be acting as a certificate throughout. And yeah, we have people from mechanical engineering, we have people from civil engineering. We had somebody who dropped out who was a PhD from civil engineering, but he had a petroleum engineering professor. Huh? Yeah, but it's very rigorous 3 days. Like it's from 9 a.m. until 4 every day, or 5 or something. It was very tiring, and small breaks. Yeah, this is why what you learn. If I do it again, I will sit down and review what we do in this class in module 4 and what we do in the previous class and also module 4 and stuff related to well control, and then I will go so that I will be well prepared. Back in our time, we only had one drilling class in Texas, but it had a lab. Okay. And the lab involved simulation exercises, and it happened to be the same simulator that we had there. But it wasn't a phone simulator, so we didn't have access to it, except when we were on the lab. It's like the small one that we have downstairs, the little one, not the big one. Now, if you do it on your phone, you can prepare yourself, because even there, you need to know the process, the steps. Okay, if you know the steps by heart, it's sort of like, and why I say by heart, know which one follows, so that you know what step is coming up. You are not sitting there looking at the screen or something. And in this class, I tried to make everything 2 exercises into 15 steps. We only saw the 4 already, which is how to start to drill, right? You increase the the pumping rate to 100 SPM, you start rotating to 60 RPM, and then you apply weight on the beat. And then you check for you check for a kick. These are the first steps. Okay, but I have the next steps that we're gonna see in the next module. And these are important. Okay, these are important. And this is one way of putting everything into one small list of steps that you can memorize and be there and you know what follows what. It's like a lawyer where they say memorize all the evidence that you have, memorize what the other guy says that you are cross-examining. So when he says a lie, when he says something that is inconsistent, you are gonna catch it. You know, you are not looking at your notes. You know it. Yeah. That's what F. Lee Bailey was saying, actually. What else I was gonna say? In that way, because when they put you in a group, one of them is acting like a company man, which is basically nothing. It's the easy spot. One of them is acting as a driller. The other one is acting as, I don't remember what. And you rotate in every exercise. Okay? So you need to know what your role is. And you need to know what step is followed. There are groups that, like there are maybe a lot of diversity. Some of them, maybe a lot of them are speaking in a different language than what is their native language. So there is a communication obstacle there, regardless. Okay, you cannot do anything about that because you will find the same thing on the rig, right? Many times I go in American Bar and Grill in Pego City. I was the only one there speaking English. Yeah.
American what?
It's called American Bar and Grill. If you drive to Pegos on your left. Why?
In John Fox?
No, in
Texas.
no, in Texas. It's 1 hour from Odessa, something like that. More than 1 hour from Odessa. It's on your. As you enter the town, there is a yacht with all the rigs on your right, but then you enter the town, and then it's on your left. It's on your left. I used to go there when they were not drilling, and I would play pool against myself. But most of the time, most of the time there's people from the oil field there, so you will find people that you know sitting on the bar or something. I had wings and sweet tea. I didn't have alcohol because if they call you back to the rig, you know, there might be a drug test. Yeah. So, yeah, that's a nice place, actually. Anyway, so that about that. Yeah, think about if you guys, well, I guess mostly the people online, if you guys are graduating and you're looking for a job, if you want to send me your CV, I will send it directly to this person. Otherwise, I bet there would be a career announcement or something in the career services of UND. So somehow you might see the opening there. But it seems like they really want people. And yeah.
What's that graduating next?
Yeah, I mean, yeah.
Plug yours.
He's
Plug yours. Start plugging.
Yeah, it's not really a job for a PhD.
Wow.
Okay, it's not for PhD.
No, it's not the job that you expect to get as a
Get the
PhD.
PhD, just
It's good for a starting.
Yeah, to start, yeah. And it's gonna be a big lifestyle change, okay? I mean,
It's good.
it's
It's highly to.
it's a dirty job. And you're probably gonna be with what's the name? You're gonna be
Derek-
with solid
Derek
control
man.
people. Huh?
deal with the Derek man.
No, you're not gonna be on the floor. No, you don't go on the floor. Yeah, it's gonna be a lifestyle change. It's gonna be a very. You want to have a base
Is
somewhere.
it going to be in the office?
No, it's not gonna be in the office. It's gonna be on the rig, and that's why I'm like,
An office on the rig.
no. Yeah, it's a trailer on the rig. It's not a good place. Like it's
But
like a,
I'm afraid I don't want to be in a job that we will be on the line, in front of line of fire. That will probably cut my fingers.
What will you go do and then fire will catch your finger?
I think most logger, they have a cubicle.
Maybe the
on
one,
the rig side.
more
They just
longer.
go to the.
yeah, they have
collect,
a trailer.
And then I'm good.
Yeah, that's
And my money is coming. And
you know,
Yeah, but you don't want to be doing that every day. And you want to, if you want to take a break, you want a company that is flexible. You say, hey, I have a wedding to go to. I want to take the day off.
Yeah.
And then I want to take from this day to this day. I think you need to be able to take it because those days off that you are not going to be getting paid for, you will be trying to apply for other job and do other stuff. Like for me, it was very different working in the rig and going back to Austin because I was staying in Austin at the time. It was like a different.
So you are talking about your experience over there.
Yeah, but it was pretty much the same job. It's it's like different world. Right?
I want to get those type of job they pay per hour or you see a salary job.
No, it depends. That depends. That depends on the company. I used to work for a company that was paying you hourly. So you punch in and you punch out and you work 12.5 hours.
I don't like hourly job. It's not
It's
good.
good now.
It's not.
They'll pay you well now.
It's not good.
No, it's
Because
good.
there are sometimes that your body could be weak, you can't go to job, then you're not getting paid.
No, you
Are
cannot
there
go
jobs
to
in
the-
US that is not paid
It's
out?
not hourly.
Well, the thing is that hourly pay
Yeah,
because
there's salary. For example,
it's
I don't know.
12.5 hour shift.
the
So
salary job now.
everything
Assistant
after 8
salary.
hours,
That
you
one
get
is-
1.5 the rate
Okay.
because it's overtime.
That overtime.
Okay, but you have to be there. You cannot not be there. You cannot call in sick or something. And so low pay, it might be a low hourly rate, but they give you hourly pay, and then they give you another payment for food per diem, another allowance for the car because you are with your car,
Mhm.
and then they give you another payment if you work on a rig with oil-based pay, like $10 a day extra.
Mhm.
And that is because you're gonna need new clothes, new FRCs, fire
Oh
retardant
my
clothing.
goodness. That's a lot, man. I get it to
So-
$60.
Yeah, it becomes a lot per day.
Yeah.
You know, the daily rate that you're gonna be making is gonna be over $100 a day. More than $100 a day, for sure. Now, I work for another company that works with a different system. It was a Colorado-based company. And Colorado companies, I mean, they may say, we're giving you $35 an hour, which is a lot, but the taxes there are horrible. Okay, so in Texas, they may give you 12 an hour or 15 an hour. 15 an hour is a very good pay. But anyway, I was working for another company and it was giving you a fixed amount. So for a 2-week period, if you work 1 day for those 2 weeks, you make at least what is worth for 3 days or 4 days. And then if you exceed that, if you work more than 4 days that week, they give you, depending on how much. So it's like there is a threshold, okay, which is good. So when I was working for that company, when I quit, I made sure I worked 1 day in those 2 weeks period. I stayed 1 day extra. Yeah, because I was, my contract at Colorado School of Mines was starting at January 10th.
Mhm.
And I left January 3rd. I did January 2nd, I did that shift as well. And I left January 3rd in the morning. Because it was so that I get that extra money, work 1 day for a 2-week period, and then you get basically, yeah, it's like I think it was a Monday or something. So you work that extra day, and then they pay you for 4 days or something. So yeah, so the payment can be good. Oh yeah, and then if you are certified to do, if your rig is in a contract where they do mass spectrometry, extra $50 a day, and if you do one more gas chromatography, $50 more a day, something like that, things like that. Yeah. Anyway, so there is an opportunity. Where were we? Oh yeah, homework 3. Sorry, homework 4. Due on Friday, but it's very easy. Okay, it's very easy, but you need to start early. Let's go over it very quickly. Yeah. Question number 1, describe the direct method for determination of fracture gradient, including the leak-off test and the casing seat test. Now, if you go here, useful resources, look at what I put. I put all the pages that are relevant from chapter 9 of Rabia. I don't think I broke any rules by doing that, any copyright rules, because it's less than 10% of the book. But you can find all the information. Just click. There you go. Picture. So it would be okay. And I think you can even find the whole book online.
Yeah, I've got it.
Chapter 9 is what you care about. Okay, so look at what it says there. Describe the indirect methods for determination of fracture gradient, pointing out where they are similar and where they are different might be helpful to skim through the relevant papers. See references in the end of module 3 slide deck. Just look at the pictures from Rabia's book. I have the 4 methods that we learned. Question number 3, why does hole inclination influence? It says, why does hole inclination influence fracture pressure and how? So if I have an angle on my well, what does it do to the fracture pressure? So the well is deeper. Now, MD, whatever, measuring depth, measured depth-wise, compared to true vertical depth. What does that mean? Question number 4. What data is needed, not are needed, for selection of proper casing seats? And question number 3. Using the data on table 1, calculate the fracture gradient, FG, not fracture pressure, using Eaton's method, assuming Poisson's ratio of 0.4 and a lithostatic stress gradient of 1 psi per foot. Add a third column for the required mud weight, which can be the formation pore pressure plus 200 psi over balance safety factor. Then add 4th and 5th columns for the formation pore pressure and mud weight gradients, respectively. Then use Eaton's correlation equation to estimate the fracture gradient and put that on a 6th column. Plot the 3 gradient lines, FPP gradient, MW gradient, and FG gradient on the, fracture gradient, I guess, on the same plot of TVD on the vertical axis in reverse order and pressure on the horizontal axis. So basically a pressure traverse plot. Well, it's going to be a pressure gradient traverse plot, FPP, MW gradient, and FG. Finally, use this plot. Huh? Yeah.
FG, Nigeria means federal government.
Yeah, finally use this plot to select the number of casing strings necessary and the shoot depth of each. This is real data, it's a real web. And you will see real well section, okay? And then question number 6, what would happen if Poisson's ratio was 0.3 instead of 0.4 used in question 5? And question number 7, if the well were inclined rather than vertical, would the casing seats in question 5 be changed? If so, in what way? And that is your homework for this Friday. Everything up to question 5 is fairly fast. Get it out of the way. Use the prints I gave you in useful resources. And then question number 5, do it diligently, in a sense of do it carefully, step by step, okay? You have 2 columns, work on the 3rd one. Then work on the 4th and 5th one. Then work on the 6th one. And then make the plot. Sorry, the plot and basically you are gonna do a casing design. Like you asked me on the first module, how do you design the casing strip? It's basically what you are doing now, yeah.
I've not really, but
Yeah,
I should look into it. So.
Yeah,
Yeah,
it's
we have
fairly
homework.
easy.
I think that's the last lecture, right? The one that we were not here last week.
No,
The
last week we
matrix.
did about the gradients, how do you calculate? We did about the Christmas method, and then we started talking about the directional drilling. So we do other stuff now. I want to go through directional drilling fast so that I get more time on the module 4, which is well controlling. These are the important stuff. Directional drilling, I just want you to learn the basics so that you can learn through, if you take an industry course or something, because directional drilling is very technological based. It is very, very computerized. Okay, I want you to learn the basics, how it's done, what measurements you do, etc., etc. But I don't want you to be doing estimations on the angle or stuff necessarily, because you are doing this computerized these days. And if you work for a company that does directional drilling, they are going to make you sit through a course how to learn how to use their tools. So it will be different from one company to another. I just want you to be ready to take these courses, and then there is no point in making you do a very hard class, very hard homework on directional drilling that is going to basically be useless mostly if you go through a industry course. But question number 5 is easier than what it seems. And then question number 6 and 7, questions 6 and 7, you need to think, okay? Just see, okay, if you change Poisson's ratio, add another column next to it, okay, Poisson's ratio 0.3, what happens? This happens, good. Okay, you prove it to me. If the well is inclined rather than vertical, will the casing seats be changed? If so, in what way? So yeah, fairly easy. That's why you have until Friday. Start early. Do 1 through 4 as fast as you can, and then spend time on 5.
Can I quickly ask a question on that number 1? I don't want to ask before, but
Yeah.
are you expecting us to talk about the direct method, talk about the lake-off test, and talk about the casing test, seat test? That number 1.
Just go.
Am I missing things up?
Let me see. Go here.
Yeah, actually, I've read through yesterday.
Oh, you went through.
Yeah.
So what it says here.
I should just,
I'm not saying copy, but understand. And it goes all the way here.
yeah, I read
Yeah.
it yesterday.
And it's basically what we did in class, but in class we went by, fast. Yeah, he makes a very good. Also, I'm trying to get you guys to read this stuff. That's the
And
main
that's of the work.
of the homework. Yeah. And then, by the way, it shows like every method that we went through class. I designed these slides based on that book. So you understand that it's, if you follow that, oops, did I? ah, Okay. No, I thought I erased the Zoom, but no, I didn't. Okay, good. So that's it about the homework. Now we need to go over some slides on drilling, and we don't have much left. But last lecture, we finished talking about borehole stability, and I did change it to, it was wellbore stability, I changed it to borehole stability, which makes more sense because borehole is an uncased section. And we talk about stuff that we see in more detail in geomechanics and drilling and well completions or advanced level techniques for the graduates. We talk about breakouts and drilling induced tensile fractures. And we said that drilling induced tensile fractures have the same DNA as hydraulic fractures. Okay, they are the same thing. Okay, breakouts are shear failures, which is very different. They are like the failures that you see when you get earthquakes. Okay, so they are not the same. And we said that people are trained, geophysicists, to check about those in image logs. So if you go to image logs, I should change that to borehole breakout or wellbore breakout. That's correct. That's correct. You see these patches that are dark. They are basically this stuff here, white and dark. They are breakouts. And then you see the narrow, very dark gear. They are drilling induced tensile fractures. And the first time you see them, you are, it looks confusing, but the more you see, the more trained your eyes become into recognizing these drilling induced tensile fractures and wellbore breakouts. And it tells you something. It has a diagnostic power. And this bullet point, the third one, makes more sense when you take the other classes. But the orientation of those drilling induced tensile fractures with respect to the wellbore is very important. It can help you constrain some geomechanical parameters that are important when you drill wells. For instance, when we're drilling a vertical portion of a well, most of the drilling induced tensile fractures are like this, aligned vertically with the well, axially. We call those longitudinal drilling induced tensile fractures. So if the well is like this, the fracture is like this. Okay? Transverse, like this, the well is like this, and the fracture is like this, are very rare. So when you see transverse drilling induced tensile fractures, they are very powerful in terms of diagnostics. They can tell you something that longitudinal fractures cannot because they are more rare. Okay? Now, for a horizontal section, it's the opposite. Transverse is more common than longitudinal. So, either way, you can say stuff. Either way. You can say something about, it tries to tell you something, okay? Image logs. They have a powerful diagnostic ability. Okay. But I just wanted to introduce it here because we are really going to talk more about those in geomechanics for the undergrads and in well completion. So I just wanted you to know about those. And then we talk about the stresses in the near wellbore region, or before that we did. And we said you remove rock and you put fluid, okay? So you disturb the stress field around the well such that if you go near the well and you look for the stress field, you're not gonna see SV, SH max, SH min. You're gonna see something else that is related to SV, SH max, and SH min, but also related to the wellbore pressure inside the well, right? So we use near wellbore stresses that are different coordinate system they're in polar coordinates or cylindrical coordinates. And we don't need to know how to calculate those in this class, but I want you to know their configuration, and I did show, excuse me, last class, how these stresses look like the direction of radial stress, the direction of tangential stress, and the direction of the other stress, the axial and the shear. So say I want to, the stresses here. I draw a radius to that point. I didn't draw it straight. I extend this radius with a green line, and this is my radial stress. Okay, where the arrow is pointing out, now it's showing tension. The other way is going to show compression. Doesn't really matter. I don't care about the direction yet. Where is I care about the direction. I don't care about the arrow so far. So I'm drawing it tension just to look better. Then I go orthogonal to it, and this is the tangential stress. Okay, also known as the circumferential stress. And then I go along the well, dot coming up or X going down, coming out of the screen or inside the screen. And this is the axial stress, sigma ZZ, okay? And then I take the pink and I make some weird arrows like this. And this is the shear. Okay, I just want you to know the geometric configuration of the stresses. I don't want you to know how you calculate them. I don't want you to know how to derive them or something. These are gonna come after. You don't care about those. Now, what if I go on the wellbore radius? Okay, I go somewhere here. And I want the stresses here. Still, I have radial stress. I have tangential stress. And I have axial stress. What about the shear stress?
Zero.
Yeah, becomes zero on the wellbore radius. Okay, so the value of those stresses on the wellbore radius are very important because this is what determines the fracture that will initiate from the wellbore radius. Okay, that's why we spend a lot of time discussing them in the other classes. I want to introduce it at that stage only. Now, and I'll talk about the long history of how you calculate them. It started with Lamé, Clapeyron.
Okay.
Yeah.
Why is it zero?
You need to see the equation for that. It cancels out.
Okay.
Yeah, it becomes zero on the wellbore radius. R over RW becomes 1, and then it becomes, you have an equation where it becomes 1 minus 1 plus 3 minus 4 or something, it goes to 0 on the wellbore radius. But if you go away from the wellbore radius, it goes to a value. Now, what will happen if I go very far away from the wellbore radius? What will happen if I come here and I want to see the stresses? Very, very far from the wellbore. What am I gonna read there?
In what sense?
Is
A
that
very
somebody?
big distance away. One of them, sigma RR or sigma theta theta, will become SH max. The other one will become SH mean or something. And then the sigma ZZ will become SV. So eventually, when you move away from the wellbore, its influence goes away and you get SV, SH max, SH mean. Yeah. You convert that into Cartesian, and it's gonna be SV, SH max, SHV. You don't need to know how, just know that this happens for now. Now, these are the stresses, these equations that we saw before, Matthews and Russell, Matthews and Russell, what am I saying? Hubbard and Willis, Matthews and Kelly, what else? Eaton, Christmas method. These equations have to do with the stresses on the wellbore radius. Okay, and I showed a little bit here how it happens. Like we talk about Lamé and Clapeyron, 1831. They were doing equations to see how much you can load a cannon before it explodes. Okay, cannon is a thick-walled cylinder. So they came up with those equations that became known as the Lamé equations for the thick-walled cylinders.
Is it from France?
Yeah, they are from France. Then Kirsch from Germany used those equations. He was a professor. He used these equations for a hypothetical problem of a plate, two-dimensional with a hole in it, with the hole having tension on it. Okay, this is basically a well with right. You have stress here, you have stress here, and then you have stress here. So this was a hypothetical problem. And he used them, but he was a theorist. It was like a plate with stress on the hole in it, with a hole inside it, stressed around, and then somebody took these equations, that I don't know who, and converted it to biaxial stress. So we have two stresses, not the same stress value. One stress here, another stress here, another in terms of value. Then Hubbard and Willis were geologists for shale. So they took Kirsch equations and they added pore pressure to them, incorporated pore pressure, more like subtracted pore pressure. But the case is going to come by, it happens a lot. Basically, you incorporate pore pressure because you are in a rock. They were the first rock mechanics people that took this theory to make use of it, right? Up to here, this was, I don't know what they were doing. They were like philosophers or math people. This was like a mechanical engineering guy, I think.
Okay.
And these were geologists for sure, okay? And they used it. They came up with this equation, the Kirsch solutions. And then you have Heinsohn and Fairhurst, who were geomechanics people from University of Minnesota. Heinsohn, I believe, is still alive.
Oh.
Yeah, and they added pore elasticity to it, okay? Which is basically accounting for the changes in the size of pores as fluid moves in and out of them. So they made it more accurate. But yeah, these were like geomechanics people. Yeah, Bezalel Heinsohn. I saw him in ARMA 2019 in New York. Yeah. He was there. I think he's still alive. I know Hubbard died in 89. Kirsch is long dead. And the others are. I don't know about, I think Fairhurst, Charles Fairhurst, he died too, because I saw a paper by Heinsohn, and he wrote dedicated to the memory of Charles Fairhurst or something. But I think there was another Fairhurst coming after or something. I don't know. I don't know them. So anyway. Actually, thank you. Heinsohn was handling something in ARMA. He was sending emails in ARMA. Listen, like, you know, the group emails. to arrange for a seminar or something. He was sending
Yeah.
like long time ago some emails because it was like, oh, if you want something, reach out to Bezalel Chaimson. Anyway, then we talk about directional and horizontal drilling. There is several reasons you want to do that. And we discussed them. We also talked about how, look at the third bullet point. You have, in the rig, you have a geologist. Maybe you have two geologists. One is acting as a mud logger, and the other one is geosteerer. Sometimes you have third parties in between these two. The mud logger says where you drilling, where you are in. The geosteerer says where you need to be, and the driller, the directional driller, says what you need to change operationally to get there. Okay, this is how it goes. The mud logger analyzes the samples from the cuttings, tells you you are in this formation. The geosteerer says, oh, you know, based on the well plan, we need to go into this formation, blah, 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 we need to go up. The directional driller says, oh, you need to tweak this on the BHA to get on the RSS, the rotary steerable system on the BHA to get there and there. Directional drillers are very weird people. Very weird people. And well paid. Anyway, there is a difference between a directional well and a horizontal well in the sense that directional well really, well, horizontal well is a version of directional well. But directional well is like, I'm trying to reach a target right there. Horizontal well is more like I'm gonna go down, kick off, hit my target and go horizontally and then fracture to get there. Yeah. Extended reach well, let's do it again, yeah. Extended reach well is more like cutting edge technology wants to, maybe I was saying the joke like at some point somebody will do it, and I think they have done it, but there is a old joke. You go to the field, football field, at the 50-yard line, the middle of the football field, and you put a tractor tire there. And we can bring a rig here, and we can tell them, make a big pass through the tractor tire on the middle of the field. It's possible. They are supposed to be able to do it. They can do that. You understand that? We put a tractor tire
At the middle.
in the middle of the field, laying down. What does it have in the middle? A hole.
A hole.
Okay, and we bring a rig here, and we drill here, and we are gonna have the bead go under the earth, and then come up the earth in the middle of the tractor tire.
How would that be feasible?
No, it's possible. Based on the technology, it's possible.
Like this, then go up.
Yeah.
Wow.
There is a video of some Russian crew. They got the bead out of the hole, and they took a picture of the bead hanging up, and the rig. You can see the rig at the back, like behind. Like they got the. Yeah, there was a video back when I was doing drilling. One of my classmates sent it to everybody. Like they drill, and they got like imagine I'm drilling here. The rig is here, and the bead came out of the ground where Coyote is. And they all went there and they took a picture with the bead behind them, and you can see the rig here. Anyway, but you can do this stuff. Well, you don't want to do this stuff. Somebody will lose his job if you do this stuff. But anyway, directional drilling is used in a number of scenarios, and I analyzed them last time. Side tracking, inaccessible locations, salt dome drilling that you want to avoid. If you want to avoid faults, I talked about how if you hit a fault, it's a bad idea. Okay, it can be okay, but it can be bad. It can be very bad. Multiple exploration wells from a single well bore. This is what we do these days in well-established regions like the Midland, the Permian Basin, or the back end, you drill parts. You drill multiple parts, actually. How do you say, there was a, when I was in Colorado, I used to hang out in a cafe, and I met a girl, she's about, I think she's a little bit older than me, a few months older than me, but she does tours, and she was posting on her page that they are gonna drill fracking wells near a reservoir in Colorado, near a water reservoir on the sea, on the surface level. And they were gonna, they were trying to sign against that. And the way they made it sound like is like those parts, they're gonna drill like a total of 32 wells. They make it sound like it's an operation that will stay there forever, you know? It wasn't like, you know, it's a temporary operation. You're gonna bring the rig, you're gonna drill multiple wells with the same rig from the same location, then you're gonna frack the wells, and then you are gonna leave. There won't even be a pump jack there probably in the first years of the operation. So it's not like gonna be, it's not like a construction site that is gonna be there forever, you know? It's, anyway, I don't think she understands, but that's why, anyway. Yeah, multiple exploration wells from the same well bore. So basically, you bring a rig there and you drill a lateral, okay? Then you have a process which is called walking the rig. You move the rig over the course of 12 hours. You move it from there to there. Very small distance, okay? 20 feet. It's called walking the rig. And then you drill another lateral. Then you drill another lateral. By the way, you drill, you case, and cement. You drill the lateral, you case, cement. You drill the lateral there, you case, cement. You have 3 laterals, 3 verticals, right? And then you stay there, and you switch to oil-based mat, and you do the horizontal lateral, which is in the shade, okay? Then you walk the rig, or you case, cement, whatever. You walk the rig here, you go on to the second vertical, you extend it to, you do the lateral, the horizontal lateral, you case, cement, etc. Then you walk the rig, you come here on the first one, you go horizontally, and you case, cement, and then you have 3 wells. And then you're gonna call Liberty or somebody to do the frac job for you, which is a smaller operation, much faster and much cleaner, to be honest. So this is how you get 3 wells from the same rig. That's the practice. It can be, I used to be in the Permian. We had, the company I was working for had contracting 2 wells that were like 300 feet from each other. And one was drilling 3 wells, the other one was drilling 2 wells. The wells belong to the University of Texas system because they have a lot of land there. But it was mixed with, the lease was a small company in Dallas, was the operator of these leases. And there were 2 rigs. One of them was vaccinated people, the other one was unvaccinated people. It was during the COVID times. Well, it was 2021, after the COVID times. And one rig was one company, the other rig was another company. And there was a time our rig was using brine because they were still doing the vertical sections. And their rig was using oil-based mat because they were doing the lateral sections at the time of those wells. But the idea was that eventually you're going to have something like 5 wells or 7, I don't remember, horizontal, going like this. And then, yes, we have that. Yeah, and you drill the verticals with brine, which is cheap. And then once you are in the shale, you need to use oil-based mat because of water stability issues with shale. Offshore multi-well drilling, and relief wells. Relief well is after you had a blowout, you want to drill another well, intersect the blown well, and pump cement through it. So that won't be a vertical well, that's for sure. Okay, you understand that the relief well won't be a vertical well. And yeah, I mean, all this stuff. And horizontal wells, of course, for development purposes. This is why you do directional drilling. Directional wells are designed and drilled following precise technical criteria in order to obtain the desired well trajectory. Horizontal drilling is the process of drilling a well targeting a subsurface location just above the target reservoir called the kickoff point. That's where you start deviating. You go vertical, and then you do the kickoff point, and then the landing point. Kickoff point is where you start the curve. Hey, Roxon, do you know the kickoff point? Let me draw so that you guys can understand. This is the vertical well, right? Okay, kickoff point, landing point, and then horizontal landing, right?
Yeah.
Okay, kickoff point is where I start my curving. Landing is where I end.
The landed well.
Yeah. So you understand that this part is very important, right? It's very tedious. So they're going to be drilling slower. They're going to be very careful.
Okay. Do you normally know the angle of the distance between?
It depends.
Okay.
We're going to talk about those, what they are called, but it depends. It's not the same for everywhere. Then deviating from the vertical plane around the curve to intersect the reservoir at the entry point. That's the landing, basically. Nobody calls it entry point in the oil field. They all call it landing. Okay. How this well landed, where it landed, did we land, when did we land, because you have to put it on the reports, and remaining within the reservoir until the desired location is reached. So ideally, this section here, all this section, this is what you are going to fracture eventually, right?
Yeah.
This is, you're going to divide it into stages, bring liberty and fracture, right?
Yeah.
Yeah. So you are really, horizontal is what you are going after. The horizontal section is what you are going after. But ability to develop a reservoir with less wells.
So what type of fracture will you now fracture over there get? Or it depends on the
Transverse to the well,
yeah.
like orthogonal to the well, ideally.
Okay.
Yeah, that's why you drill your well. You have your lateral in the direction of SHD. We learn about that in geomechanics and yeah. You want to drill it in a way that you make it likely to get transverse fractures. Ability to develop a reservoir with less wells, since a horizontal well can drain larger rock volumes than a vertical well can, therefore reducing the aggregate surface footprint of the operation. So from one rig staying basically there, you can drill 4 or 5 wells, right? Which is nice. The use of a horizontal well can reverse or delay the onset of production problems that prompt low production rates, low recovery factors, and premature well abandonment. I think you can understand that. Directional wells, different types. Built and hold, you have several types of wells. Broadly speaking, the drilling of a directional well has the following operating stages.
Andreas.
Yeah.
So why do they have to even drill a directional well for the first time instead of not going through the
When did they drill a directional well?
Why?
Why?
Yeah.
Because you have the target formation is horizontal, right? Okay, if you drill a vertical well through that, okay, let's draw this. I will make it black, the target. This is my target, okay? It's my shale
Yes.
reservoir. It can be a sandstone reservoir, doesn't matter, okay? If I drill a horizontal well like this, I perforate this, even if I fracture that, and I make two gigantic longitudinal fractures
Yeah.
like this, how much is it exposed? Am I exposed?
That is vertical well or horizontal?
That's a vertical well.
Yeah.
I'm only exposed to this part of
Yeah.
this small part of the reservoir, right? Now imagine if I drill a vertical, if I drill a horizontal well, I can go, you want it yellow, okay. You go like this, kick off, go like this. Then fracture it transversely.
You have enough flow.
Yeah, how much of the reservoir is exposed to my well now with one well? So much.
Yeah.
Otherwise, to get this much, how many vertical wells would I have to drill? I'm gonna have to drill one, another one, another one, you know, and then try to get everything. So with one well, I achieved what I would have achieved with multiple vertical wells before. More than three, actually. So that's why we go horizontally, sorry. So broadly speaking, the drilling of a directional well has the following operating stages. Beginning of drilling, deviation of the well, that's the kickoff point. Yeah.
Yeah, my question was regards to the directional well and then the horizontal well.
Oh, okay, that's a
Yes.
good question.
Yes. No.
Yeah. Not there again? Okay. Directional well is, well, horizontal is a version of directional well. But directional well in general, you are moving up and down, you are trying to avoid stuff, you are trying to direct it a certain way. Horizontal well is a very, very perfect, idealistic version of a directional well. That is, okay, I'm developing this region and these are my horizontal. It's not that horizontal is a very, very perfectionist term. It's more of it's a directional well that is almost entirely horizontal, you know? Constant inclination, okay? S-shaped hole to reach a target or decrease in the inclination angle to a predetermined value at the established depth. The inclination of the whole path begins to be decreased by a prefixed gradient and drop-off rate. And this is where you see here, you have type 1 well, which is kickoff, you build up the angle, landing, and then you go straight. But it's not exactly horizontal, right? It's the L-shaped well. It's not horizontal here, but it can be horizontal if you kept building angle here until it becomes like this, right? So this could be horizontal, right? This could be horizontal, very easy, right? This one is type 2M kind, but there are many types of wells, to be honest. Kickoff, end of build, and then you keep going straight, and then you drop down. Start of drop, end of drop, and then you hop. Okay, so like this. More like S shape, but it's M type, as they call it. Some people call it S type of well. And then you have this here, which is basically type 3. What is it? You kick off and then you build up and you hit your target. This would be a relief well, mostly. There is no wells that are perfectly like this. They are all a combination of. But I want you to know what is a kickoff point, what is the landing point, that's the end of the build, what is the drop-off point, start of drop, what is the end of drop, I want you to be familiar with this, but don't memorize types and yeah. They all come up with a new set of types every
Time.
every time, you know. So it's like I don't really want you to spend your time on stuff that are not established. So tools for deviation, two ways you can deviate your hole. One is by pointing the bit, and the other one, 1 second, I think I have a mistake here. Several systems for establishing and carrying out well deviation, and some of them have been highly improved in recent years, particularly since the carrying out of the extended reach drilling and long horizontal wells, which is what we do today. Okay, that's fine. That's fine. The drilling industry has gone from using a whipstock and jetting to the systematic use of downhole mud motors and rotary steerable systems. Now, what is a whipstock? It's a metal wedge. It used to be wooden. They were wooden that you put at the bottom of the bit. Oh, they're here.
Yeah, I get it.
Okay, we're gonna go through it next time. So we're gonna learn about whipstock, point the bit, and push the bit, and we will learn what you need to adjust to get the angle that you like. Work on the homework. I have office hours today. They are gonna be early, 12 to 3. And yeah, if you want me to send your CV to the person from that company, I would be happy to send it to me.
Move forward our
Yeah.
cities.
Always send a PDF of your CV, not a Word document, okay? So that well, they can make changes in the PDF, but yeah, I mean, it's more proper to do that. Okay, anyway, yeah, and any questions, come to the office hours or send me an email or a text or something. And yeah, I will see you all on Thursday.
Thank you, sir.
Yes, I will see you guys. Okay, let's get lost. Thank you, Donald. In the other class, the guy was, another professor was teaching until like 1 minute